Here are the chapters. We are done with first 6 of them. Algebraic expressions, simple IGCSE, quadratics, solving quadratic equation either by midterm breaking or completing square or quadratic formula, quadratic graphs. This included the transformation as well. Either the graph is moving up, moving down, left or right. This could be done from the completing square form of equation. Discriminant used to tell you either we have 2 points of intersection, 1 point of intersection, or 0. Equations and inequalities were mainly simultaneous equations. Graphs and transformations, cubic graph, quadratic graph, uh, reciprocals. First you equate it with 0 and you get the factors, and having those factors you can tell where it intersects the x-axis. Chapter 5, straight line graphs. Again, repetition of O levels, coordinate geometry. Chapter 6 was circles. It included mainly making of completing square, but we also did the method to find the equation of the circle with the direct method using formulas. Then the concept of tangent and chords would include chapter 5 again, coordinate geometry, and chapter 3, simultaneous equations. If there's no issue, we can start with chapter number 7, algebraic methods. Okay, algebraic methods. What do we have? This is simple algebra and would include mainly factorization of polynomials. You can simplify algebraic expressions using division. You have these two. Either you factorize and then cancel out the numerator and denominator, which are of equal values. Example questions. Let us start. Suppose you have this question number 8. So I can write 7x4 over x, or splitting them, and or even a better method would be taking out x as common. If I take out x as common in the numerator, because I can see x in the denominator. So this is 7x cube minus 2x square plus 6 over x. You get rid of this x in denominator. This is your answer. So the fraction is already simplified. In B part, we can see 2x minus 1 in both numerator and denominator. Cancel this out. The only answer is x plus 7. In C part, we can see there is a quadratic equation in numerator, and denominator there is a linear factor. So if we see, this is 12, and 12 is actually 4 times. If we do the midterm breaking of the numerator, this is x square plus 4x plus 3x plus 12. See, if we add 4 plus 3, we get 7. If we multiply 4 and 3, we get 12. So x into x plus 4 plus 3 into x plus 4. So you're left with x plus 3 and x plus 4. So in the numerator, you can write x plus 3 times x plus 4, and denominator is already x plus 3. So simplifying this expression, you can write x plus 4 as your answer. We should move on to the exercise. This is example 1, exercise 1. Question number 1 is again a simple one with only one of the factors in the denominator. So you just take x as common in the numerator. If you take x as common, you're left with 4x cubed plus 5x minus 7. And in the denominator, there's x. So you get rid of this. This is your answer. Again, we have single number, and in numerator, we have two different numbers. So if you divide these, we can take x as common. This is 7x 4 minus 5x 4 plus 9x square plus x divided by x. Get rid of this x, and we see that we have two x4s. So 7x4 minus 5x4 is minus 2x4 plus 9x square plus x. It says simplify. If it would have been factorization, we will do it till we get the linear factors of all. Last part says again denominator, it is x. But in numerator, we can see that we cannot take x as common from all these terms. So what you can do is, we can try if we can get the midterm breaking first. If that is not the case, we will just split them into fractions. So let us check if we can find this. So 1 into 6 is 6. So 6 is either 1 into 6 or 2 into 3. So 1 into 6 plus minus, we don't get 4. 2 into 3 is 6 plus minus, we don't get 4. So we'll go into splitting. X4 by x plus 4x square by x plus 6 by x. So this is negative x cube plus 4x plus 6 by x. This is your answer. Is it clear till now? Yeah, Mohammed. Any issue? Okay, Mohammed is a thumbs up. Okay.
Yeah.
So let us try question number 2. First few parts, they are already simplified. So x minus 2 goes with x minus 2. Your answer is x plus 3. Second part, 3x minus 1 goes with 3x minus 1. Your answer is x plus 4 straight away. C part, we have same numbers. So this square goes with the denominator and you're left with x plus 3. D part. Now the D part requires some midterm breaking. So this is chapter number 7, exercise 7A, question number 2, part D. That is x square plus 10x plus 21 over x plus 3. So in the numerator, we have something like this. So 21 is actually 7 times 3 equals 21. So plus 7x plus 3x. If we add 7 and 3, we get 10. If we multiply them, we get 21. So in the numerator, you have x into x plus 7 plus 3 into x plus 7. In denominator, that is x plus 3. We can already see that we'll get rid of x plus 3, but we have to show the steps. So this is x plus 3 again. Get rid of this, and your final answer is x plus 7. So D part, it is x plus 7 when you simplify this. Are you getting the idea?
Yes, sir.
Okay, try E part with me. Question 2, part E. Is x square plus 9x plus 20 divided by x plus 4. So 20 split of 20 is 1 into 20 or 2 into 10 or 4 into 5. So we can see that adding 4 and 5, we get 9. So x square plus 5x plus 4x plus 20 over x plus 4. X common, x plus 5 plus 4 common, x plus 5 and x plus 4. So take out the same brackets as common. x plus 5 times x plus 4 over x plus 4. So the final answer is x plus 5. So this turns out to be x plus 5. Let's increase the difficulty level. If we look at this G part, now we have two quadratic equations in numerator and denominator both. X square plus 2x minus 15. So we have to do two midterm breakings in numerator and denominator. So it is 20, and we are getting 1. So again 5 and 4. So x square plus 5x minus 4x minus 20 in order to get positive 1 and negative 20. And in the denominator, x square minus 15. We are getting 3. So 5 and 3. 5x minus 3x in order to get 2. So in the numerator, x into x plus 5 minus 4 into x plus 5 divided by x is common, x plus 5, and then minus 3 into x plus 5, x minus 4 into x plus 5 divided by x minus 3 into x plus 5. So x plus 5 cancels out and we are left with x minus 4 over x minus 3. You see, this chapter again includes chapter 2. Quadratics is the most basic and most important chapter in all of your chapters. And there's a touch everywhere. Okay, please try this H part and share your answers. If we'll be having different answers, I'll solve this question. H part. G, what is the answer? Did someone get it?
I'm almost done. This one.
What about Yahya and Muhammad? Are you doing it?
Yes, I'm also almost finished.
So wouldn't it be easier if I factorize the entire numerator? So for example, if I did 2x, I did minus 3, then another bracket I did x minus x plus 6. Would that be
Yeah,
easier or is
yeah,
that wrong?
there's no issue. You can do them separately as well, but make sure you do it in such a manner that there's no confusion for the checker. If
Hmm.
you split them and then rewrite, like suppose you do x square plus 3x plus 2 first. Is this the same thing you're telling me? If you do it in this way, this is x plus 1 plus 2. Yes, Mohammed?
I just wanted to say I got an answer.
Okay, we'll just compare these. Just a minute. 5x plus 4, and this is x square plus 4x plus x plus 4. So x plus 4 plus 1, x plus 4. So this is x plus 1 and x plus 4. You can also do it in this way and then replace. So we had this, and the split is this: x plus 2 times x plus 1 divided by x plus 1 and x plus 4. G, do we have the same answer?
Sir, can you show the question again? I think I did the wrong question.
Yes.
This was the question.
Sir, I got x plus 2 over x plus 4.
I did K instead of H.
We have the same answer, 2 by 4. Okay, we'll do K as well. Mohammed, we have the same answer. Okay, question 2K. This is 2x square plus 9x minus 18 over x plus 6 times x plus 1. So midterm breaking in the numerator, 2 into 18 is 36, 2x square minus 18, and 36 is 1 into 36, 2 into 18, 3 into 12. So 3 into 12 will serve our purpose, plus 12x minus 3x into x plus 6 and x plus 1. So first 2x is common, that is x plus 6. Minus 3 is common, x plus 6 again. X plus 6, x plus 1. 2x minus 3 into x plus 6. And in the denominator, x plus 6 into x plus 1. G, Maha, do we have the same answer?
Yes, sir, this is the question I was talking about. For the top, I just simplified it into 2x minus 3 and then x plus 6. Is that right, or should I show all the working out?
Yeah, the working is required. There are marks for the steps. Working is
Oh.
required.
Okay.
You would have done it somehow. So wherever you have done it, just do it in the answer space. So that's all that is required.
Okay.
Let's try this question number 3. Gives a different feel. Question 3 says 6x cubed plus 3x square minus 84x over 6x square minus 33x plus 42. And it is equal to ax times x plus b divided by x plus c. So we have to find a, b, and c. Actually, we'll be simplifying the left-hand side in order to get a, b, and c. And then we'll compare these. So if I see we have cubic in the numerator, so I'm taking out 3x as common. I think 84 is, let me use a calculator. 84 is also divisible by 3. Yes, that's 28. So I'm taking out 3x as common. So we are left with 2x square plus x minus 28. And in the denominator, we have a quadratic equation already. So 6 into 42 is 252. Thinking about the middle term breaking, 2 is 126, again 2, 63, with 3 is 21, with 3 is 7, with 7 is again 1. So we have to shuffle these numbers to get 33 as the addition. Multiplication will always give you 256. So I'm trying 4 with 3, 3 times 9, and 9 into 7 is 63. So this is not the choice. Then we try 2 times 4, 4 3 times 12, 12 and 21. So 12 and 21 give me 33. 6x square minus 12x minus 21x plus 42. These are the two midterms. You can choose any method to split them. So 3x, and in the numerator we had 2 into 28, which is 56, and 7 8 times is 56. So 2x square plus 8x minus 7x minus 28 over 6. X is common, this is x minus 2, and then minus 21 is common, this is x minus 2. Numerator is 3x into first common is 2x, x plus 4 minus 7, x plus 4, and in the denominator 6x minus 21 times x minus 2. Keep simplifying. 3x, this is 2x minus 7 into x plus 4, these two brackets, and then we can also take out 3 as common, and we are left with 2x minus 7 into x minus 2. Now there were two things. One is the comparison, that is ax into x plus b over x plus c. So we'll know to what extent we have to cancel. So this exactly goes with this. This is 3 1 times, 3 1 times again. So x times x plus 4 over x minus 4. So by comparison, A, B, and C, A is 1, B is 4, C is minus 4. Any doubts in this part?
No, no, sir.
No, sir.
Thank you. So this is just the simplification and comparing the coefficients. Next concept is dividing polynomials. It is the same way we divided the numbers, but this time these are variables. So let's recall with numbers and then try this example. If I tell you to divide 7 with 2, there are different answers, 3.5 or 7 by 2 or 3 whole 1 by 2. If I tell you to do it and show by long division, so this is the way, 2, 3 times 6 and 1 is remainder. So this is 3 whole 1 by 2, which is remainder, and this is divisor. 7 is the dividend. So we will be doing something like this. Suppose the question tells you divide x cube plus 2x square minus 17x plus 6 by x minus 3. If you have to divide these two. Now this is such a thing that we cannot actually get a quadratic form without simplifying it. So first numerator comes inside, 7 cube plus 2x square minus 17x plus 6, just like we placed 7 inside and the denominator outside. So numerator inside and denominator outside. Our first attempt is always looking for a number if we can get the exact divisor or the exact number. So 2 5 times 10. But in the case of 7, it was 2 1 times 2, 2 2 times 4, 2 3 times 6. So the closest number was 6. So either we get the same number or we get the closest number. So my first target is to get x cube. In order to get x cube, I'm thinking of multiplying it with x square. So when I multiply these two, x into x square, I do get x cube. Then 3 into x square is negative 3x square. Next step was, if you look at this, we subtracted these two. 7 minus 6 is 1. 10 minus 10 is 0. So we'll subtract these again. So the first sign was positive. When you subtract these, the signs changes. X cube goes with X cube, and you're left with 2x square minus 17x plus 6. First thing. We keep on doing it till we reach the remainder. Now this is 2x square. In order to get 2x square, I'm multiplying it with 2x. So x into 2x is 2x square. Minus 3 into 2 is negative 6x. Again, you change the sign. This was positive, becomes negative. Negative becomes positive. This cancels out. And 17 minus 6 is minus 11x plus 6. Keep going till the end. So if we multiply it with negative 11, we can get x into negative 11 is negative 11x, and minus 3 into 11 is plus 33. You change the signs and subtract. So 33 and 6, the difference is 27. Now we can say that this equation is actually equal to this whole, which is x square plus 2x minus 11 whole plus the remainder is minus 27 over x minus 3. Like the same way we can write it 3 plus 1 by 2. The remainder could be written as plus with the whole number. What was the demand of question? It said divide this by this. Okay, so this is the answer. X square plus 2x minus 11 whole minus 27 is the remainder. And x minus 3. And I just made a mistake and no one got that. But this was 5x square, a copied 2x square. Let me quickly redo it. Did you notice this? 2 and 2 should be 5. X into x square is x cube. 3 into 2 is 3x square. Positive, negative, negative, positive. This cancels out. This is 5x square minus 17x plus 6. Then you divide it again, plus 5x to get 5x square. 3 into 5 is negative 15x. You change the signs, cancels out. This is minus 2x plus 6. Then you divide this with minus 2. So minus 2, this is minus 2x plus 6. You change the signs and the remainder is 0. So when you divide these two, so this is x square plus 5x minus 2. Because there is no remainder, this is the answer. Just like we divided 10 with 2. When there is no remainder, 10 by 2 is equal to 5. There is no remainder to it. Clear?
Yes, sir, clear.
Another question. This is all long division. X cube plus 2 x square. This is the same question, I think. X cube minus 2x square, x minus 3, x minus 3. This is the same question. Next question. 4x4 minus 17x square plus 4 divided by 2x plus 1. 4x4 minus 17x square plus 4 divided by 2x plus 1. So we have to get the first number as it is. So I'll multiply it with 2x cube. 2 times 4. X into x cube is x4. Plus 1 into this is plus 2x cube. Subtract it carefully. These two goes with. There is no number in x cube, so minus 2x cube minus 17x square plus 4. Now there is 2x cube, so 2 is already there. Minus x square. 2 into minus x square is minus 2x cube. 1 into this is minus x square. Signs changes. So this is negative 16x square plus 4. To get 16, we multiply it with negative 8x. So minus 16x square minus 8x. We change the signs, cancels out. We're left with 8x plus 4. So 8x is 2, 4 times 8 plus 4. This is 8x. 1 into 4 is 4 minus, cancels out. The remainder is 0. So 4x4 minus 17x square plus 4. When divided with the 2x plus 1, the answer is 2x cube minus x square minus 8x plus 4. So when we don't make a mistake, we actually solve the question quickly. Can you try this question number 1? Let me write the question. X cube, exercise 7b, question number 1, part A. X cube plus 6x square plus 8x plus 3 divided by x plus 1. Please try this question.
How do we times it by x plus 1 or divided?
We divide by x plus 1. X cube plus 6x square plus 8x plus 3 and divide by x plus 1. So first is to get x cube, we multiply it with x square. X into x is x cube. 1 into this is x square. We change these signs and we get our answer 5x square plus 8x plus 3. Next step. To get 5x square, we multiply it with 5x. X into 5x to get 5x square. This is 5x square. Then 1 into 5 is 5x. We change the signs and subtract. Then to get 3x, multiply it with 3. 3x plus 3. Then you change the signs and subtract. So when you divide these two, your answer is x square plus 5x plus 3. There's one more method which is known as synthetic division. Normally it is not given in the books. So I'll have to check if it is allowed to use or not. That is even quicker method. Let me just have a quick overview. What else is required? Divide this long division, long divisions. Factor theorem is something interesting. To show that if it is a factor, okay. Till exercise 7B only, which we are currently doing, is a little hectic, and then it will be smooth and simplified form. Okay, I'll introduce the quicker method as well. Let us try question number 17 and you'll see. Question 17 says that divide it with the given number and find the remainder. Question number 17. This is x cube plus 6x square plus 5x minus 12, and it says divide it with x minus 2 to find the remainder. So one method is this. If you divide it, in order to get x cube, I have to multiply it with x square. X cube, then 2 into x square is negative 2x square. We change these signs and subtract. This becomes 8x square plus 5x minus 12. Then to get 8x square, you multiply it with 8x. So 8x square, 2 into 8 is minus 16x. We change the signs. So 16 and 5 is 21x minus 12. So to get 21, we multiply it with 21. So this is 21x. 2 into 21 is minus 42. Change the signs. So 42 minus 12 is 30. So we can say the remainder is 30. Any confusion till now?
So is this a synthetic division you're talking about? This method?
This is not synthetic division. I'll have to check that.
Okay.
That is a quick method. But there is
So far,
still something there is still something which is part of your course, even quicker and easier than that. We'll just compare these two on left and right side. Side A and side B. Right now, we'll compare these two methods. So is there confusion in method A?
No, sir, no problem.
Okay, let's do our second method. Whenever you are given with a polynomial, we also call that a polynomial 3x cube plus 6x square plus 5x minus 12. And the question is telling you to see what is the remainder when it is divided by x minus 2. Always do this. Put it equal to 0. Then x is equals to 2. You substitute this x is equal to 2 in the given polynomial. And if there is any remainder, you will get it. So this is 2 cube plus 6 into 2 square plus 5 into 2 minus 12. 2 cube is 8. 2 2s and 4, 6 is 24. 5 2 times 10 minus 12. So 8 plus 24 plus 10 minus 12, I'm doing it on calculator, is 30. So you see, we get the same remainders. If you want to try this question, you see there was 0. But here the demand of question was different. It said to find the quotient. If it would ask you to find the remainder, this is 0. If we will use x minus 1 in this, we'll again get 0. Let's try with B part. It says divided with x plus 3. The same question with x plus 3. So this is x cube plus 6x square plus 5x minus 12 divided with x plus 3. Again with both methods. X square, please be with me if there is any a mistake in writing. Please do catch it at on spot. This is x cube. X into 3 is plus 3x square. We change this sign and subtract. So 3x square plus 5x minus 12. Second step, to get 3x square, we multiply it with 3x. So this is 3x square, 3 into 3 is 9x. We change the signs and subtract. Minus 4x minus 12. To get minus 4x, we multiply it with minus 4. So minus 4x minus 12. Change the signs and the remainder is 0. And method B. This was method A. Method B. The question was x cube plus 6x square plus 5x minus 12. Whenever it tells you to check the remainder, when divided by the x plus 3, put it equal to 0. The value of x is minus 3. So we put minus 3 in this polynomial. So minus 3 cube plus 6 into minus 3 squared plus 5 into minus 3 minus 12. This is minus 27. 3 times 9. 9 into 6 is 54 minus 15 minus 12. So minus 27 plus 54 minus 15 minus 12 is 0. So you see, both the methods, they leave the same answer. That depends. If the examiner is asking about the quotient, then we do not have a choice. If he's asking about the remainder, we can straight away put the value of x in that. Let us quickly try another question. Look at question number 19. Question number 19 says that f of x is equals to this. Show that 4x minus 1 is a factor. If a number is a factor, the remainder is always 0. For example, 2 is a factor of 10. So the remainder is 0. It is 2 5 times 10. The remainder is 0. So question number 19. F of x is equals to 12x cube plus 5x square plus 2x minus 1. And it says check if 4x minus 1 is a factor. If 4x minus 1 is a factor, you always put it equal to 0. 4x is equals to 1. X is equals to 1 by 4. So we substitute 1 by 4 here. So 12, 1 by 4 cube plus 5 into 1 by 4 square plus 2 into 1 by 4 minus 1. So use your calculator. This is 64, 5 over 16, 2 by 4 minus 1. So I'm using my calculator. 12 divided by 64 plus 5 divided by 16 plus 2 divided by 4 minus 1. The answer is 0. So this 0 proves that 4x minus 1 is a factor. Any doubts?
Since it's zero, I don't understand how does zero prove that it's a factor again?
Okay. Tell me if 4 is a factor of 20.
Sorry.
If we write the factors of 20,
Yes, 4 is a
factors of
factor.
20, we know 1 is a factor, 2 is a factor, 4 is a factor, 5 is a factor, 10 is a factor, and 20 is a factor, right? So
Yes.
whenever we divide with the factor, the remainder is 0. Choose any
Okay.
of the factor. Whenever we divide, the remainder is 0. So having a remainder of 0 means it is a factor. Okay. If it asked about that show that it is a factor, we can use this quick method. But this to second part of it, it said write f of x in this form. So now we are bound that we will be using long division because we now need to find the quotient. So it is 12x cube plus 5x square plus 2x minus 1 and divided by 4x minus 1. So long division. In order to get 12x cube, it is 3x square. 4 3 times is 12. X into x is x square is x cube. Minus 1, negative 3x square. Change the signs. Subtract 8x square plus 2x minus 1. Again, we can get it by plus 2x. 4 into 2 is 8. X square minus 1 is minus 2x. Positive, negative, negative, positive. You change the signs, you get rid of this. This is 4x minus 1. So you see, we get 4x minus 1 again. So with 1 only, we get 4x minus 1. Change the signs. And this is 0. So we can write this like this. 4x minus 1 into 3x square plus 2x plus 1. If the question tells you to factorize completely, if it tells you to factorize completely, the next step would be to do midterm breaking of this side. And if there is no midterm breaking, this is your final answer. G. Look at question B. It
Sure.
says, hence, sorry,
Oh no, so I was just saying I understand that question.
19b. Hence, show that the equation this has exactly one real solution. It has exactly one real solution. So it is the same part. Okay, same part. So I'm using the previous answer. It said it has only one real solution. So luckily, we already have this and we have already shown that 4x minus 1 is the solution. Now we are checking for if we have any other solution or not. So 3x square plus 2x plus 1. If we have any solution, we will get the midterm breaking. But it already said that they do not have a solution. That means it will not intersect the line. So I'm checking for b square minus 4ac and it should be positive equal to 0 or negative. What should it be if there is no solution?
What do you mean, sir?
Negative.
It is negative. Negative b square minus 4ac means no solution. Remember chapter 2, quadratics? B square minus 4ac greater than 0 means two solutions. B square minus 4ac equal to 0 means single solution. And being negative less than 0 means no solutions. And obviously, it could be upside down. depending on the coefficient of x square. So this was it. Do go through exercise 7A, 7B. And we'll start with 7C. And as I said, that 7C is a bit easier. The very last thing which we did, that substituting the value to check if the remainder is 0 or not, this way. If x plus 3 equal to 0, x equal to -3. 7C is something related to this. Any questions?
No, sir.
We'll continue from here tomorrow, inshallah. Take care. Allah Hafiz.
Allah Hafiz.
Hafiz.